All right, so as we get into this final lesson of Unit 5, hopefully this one is pretty easy compared to everything else that we have learned. Just we have to remember what a term is. So a term is anything that is separated by addition or subtraction inside of an expression. As we get into this lesson here, we want to be able to say that we can use different properties of operation in order to make an expression into its simplest form. So we're going to take and combine like terms. And what we're talking about when it comes to these properties of operation, one of them we just did in our previous lesson, the distributive property. Another one is the commutative property. Now, the commutative property should be one that you have learned previously, but it just simply means that I can move things and still get the same answer. The only time that works is addition and multiplication. If I have two numbers that I'm adding together, I can do them in either order. If I have two numbers that I'm multiplying together, I can do them in either order. I'm going to get the same answer. So commutative property, if I think about the idea of commuting, to go from one place to another in order to move. So we can do adding, we can do multiplication, once again, in any order. It doesn't matter if they're variables or not variables. They can be variables, they can be numbers. It does not matter. I can do them in any order and still get the exact same answer. Generally, when we have things like exponents in this example, we always want the one with the largest exponent moved to the front. But as we're going through this, then we also have what is called the associative property. And this, once again, will apply to multiplication as well as addition. When I said I can do them in any order, if I have more than two, then I can also group them in any order. So notice in the example there in the box, it says that 3 plus, in parentheses, 4 plus 7 is equal to. I can move those parentheses and do the addition in the front and then add 7 to it at the end. Multiplication works the exact same way. Doesn't matter where the parentheses are, as long as all that's in the math expression is addition, or all that's in the math expression is multiplication. And it does not mean or matter if it's variables or whole numbers. The distributive property is what we did in our previous lesson. So we know that we can distribute in, we know that we can distribute out. Distribute in means I have my greatest common factor on the outside of my parentheses. I'm going to multiply it by everything inside and keep the sign that's inside. So we see that top one, 3 times x is just simply 3x. I keep my addition sign, and then 3 times 8 is 24. Or we can distribute out, meaning I have an expression, but I have a greatest common factor that I can take out of each of my coefficients. When I see that 24 and 6, that I have a greatest common factor of 6, I can divide each of those and put it on the outside of parentheses. So I would do 24 divided by 6, and then I would do 6 divided by 6. And that's how we get the 6 times, because that's the greatest common factor. It goes outside the parentheses, whatever's left. And so 6 goes into 24 4 times. We keep our addition sign, and 6 will go into 6 one time. We don't want to have that 1 written in front of the x, because as we get further along in mathematics, then it just doesn't work right. The identity property is the fourth one, which we haven't really talked about. I introduced it several lessons ago, but not a big deal. It just simply states that if I add 0 to anything, the number doesn't change. If I multiply by 1, the number doesn't change. So identity properties mean that the number will always stay the same. The only way that works in addition is if I'm adding 0. The only way that works in multiplication is if I'm multiplying by 1. Therefore, when we look at the bottom there in variables and it says a times 1, or we'd have 1a, it's just simply a, because it wouldn't change. All right, so identity property, once again, if I add 0, then it doesn't change the value. If I multiply 1 by 1, it doesn't change the value. Once again, if we have that understood coefficient of 1, We don't want to keep it in front. We just know that with the a or any variable, so when I'm looking at expressions, trying to decide if they're equivalent, if they're equal to one another, then I just have to do whatever math I possibly can, such as combining like terms. So like terms is if they have the exact same variable with the same power, because sometimes you are going to see like a to the third power and x to the second power, or just a t by itself. If it's a t by itself on the left and a t by itself on the far right, then I can put those together. But I can't take something like a to the third power and add a to the second power because those are not the same type of terms. If they're constants, just numbers by themselves, I can combine those. So let's look at some of the things I'm talking about there. So when I have these two math problems and math expressions, they want to know, are they going to be equivalent? Well, in order to be equivalent, I have to do all the math that I possibly can. I see that I have a 4 on the outside of the parentheses. We know that's our distributive property. Therefore, we have to distribute n. We have to multiply by our greatest common factor, which is 4. So I'm going to take 4 times 2, and that's going to give me a product. And then I'm going to take 4 times 3. So 4 times 2 is going to be 8x. I keep the addition sign. And then 4 times 3 is 12. I'm going to keep the addition of 5. Now in the associative property, then I know that if it's all addition, then I can do it in any order. So I'm going to group the constants because they are like terms and just simply add those together. So I end up with 8x plus 17. What else can I do in that math problem? I can't do anything. And when I look at the next one, 4x plus 3, there isn't any math inside of those parentheses that I can do. However, what I can do is I can move the parentheses to where they are around the like terms because I have only addition in this math problem. So once again, the associative property tells me I can do addition in any order and still get to the same answer. So I'm going to take the 3 and the 5 because they are like terms. They are both constants. I'm going to add those together, and then I'm left with 4x plus 5. So now when I've gotten as far as I possibly can, I have simplified the expression as far as I possibly can. The question is, are these two equivalent or not? And that is a no. These are not equivalent. So when I see this symbol, an equal sign with a slash through it, that means not equivalent. Or you can write not equivalent, but I think the equal sign with the slash through it is easier for you. So what about this one? It says to simplify the expressions and draw a conclusion. Are they equivalent? Are they not equivalent? Once again, I'm going to combine like terms. So my first thing I'm going to do is I'm going to do my commutative property. And once again, to commute means to move. So I want to put my like terms together. I have some constants there, right? So if I have an 8 and I have the 2, those are constants. So I just want to move those together. So the book's showing you that I keep the 3 in, and then I'm just going to move the plus 8 plus 2 to where they are together. And then I can do my associative property because they are like terms, because they are both constants, I can add those together. I keep the 3 in plus, and I get 8 plus 2, which is 10. Now I'm going to go through the same process, but I'm going to first do my distributive property because when I multiply into, I have 3 times n, keep the addition, and then 3 times 1. Well, when I do my distributive property then, 3 times n is 3n, plus I keep my addition sign, 3 times 1, which is 3. Then I have my addition of 7. Now I'm going to use my associative property. I'm going to add any like terms that I have, and hopefully I see I have 2 constants, so I'm going to add those together. I keep my 3 in, I add 7 and 3, and that gives me 10, and I see that I have 3n plus 10. Both of them are 3n plus 10, so I know that they are equivalent one to another. All right, so when it says to simplify the first expression, then simplify the second expression, we want to figure out, are these going to be equivalent or not? So I have to start with my distributive property. right? On the first one, I have 3 times x. Well, 3 times x is 3x. I'm going to keep my addition sign, and then 3 times 7 is 21. And then I'm going to keep my addition of 2. I'm going to use my associative property. I'm going to combine my constants. So I have 21 plus 2, which gives me 3x plus 23. All right, so now I have 5 plus 3 times x plus 6. So we're going to keep the 5 plus because I need to do my distributive property to figure out what's inside. So when I have 3x, that's 3 times x, and then I have the addition sign, and then I'm going to multiply the 3 times the 6. So 5 plus is kept, 3 times x is 3x plus, and then 3 times 6 is 18. All right. Well, my commutative property tells me that I can move things around, right? And so if I move things around, I can shift, I can move the 3x to the front, and I can also move the 5 to the back to be added to the 18 because they are both constants. So when I do that, then I can add my constants together. Once again, that's the associative property. Since it's all addition, it's not going to change my answer. So I'm going to add 18 and 5, and that's going to give me 23. So we can see in the second one that we end up with 3x plus 23, which is what we had the first time. So we would end up answering and saying, yes, they are indeed equivalent. So what do we do on this crazy one? It has fractions, and then there's a fraction with the distributive property. Well, what I'm going to suggest is that we look at the first one and compare it to the second one where we have the 1/2 on the outside. And I see that there's a 1/2 and a 1/2 with A and B. So if I distribute out on that first one, I find my greatest common factor of 1/2, then I know I can divide each of those by 1/2, or basically just remove it, get rid of it since it is the same number. Then I have 1/2 on the outside, and then I'm just left with the A plus the B on the inside. And notice what the second one is equal to. So they are equivalent one to another. Hopefully this seems really easy so far, because it should be. Well, what about this scenario? All right, so it says that we have y plus y plus y and 3y are equivalent expressions. Is that true? Well, these are like terms, and they have that understood coefficient of 1, right? So one of the ways that we can figure out if they are equivalent one to another is by plugging in a number for the variable. So here they say, well, try it with a 0. If y is equal to 0, then instead of y plus y plus y, I would have 0 plus 0 plus 0, and that is 0. Instead of 3 times y, then I would have 3 times 0, and 3 times 0 is 0. So it indicates that those are indeed equivalent. Well, let's just check it with something else just to make sure. So if I plug in with the 5 and I check it, and I say that instead of y plus y plus y, I have 5 plus 5 plus 5, well, 5 plus 5 is 10, plus 5 is 15. If I plug it in for the second one, and I say now instead of 3 times y, I'm going to have 3 times 5. Once again, a number touching parentheses means multiplication. 3 times 5 is what? It is also 15. So I would be able to say that these are equivalent one to another. When I look at these type of examples, then I have to determine if they are equivalent one to another or not. So when I look at my distributive property, right, some of you have a tendency to jump into distributive property and you try to go through it quickly. That's what I saw in the last lesson. And you didn't think about everything that needed to be done. So let's look at what needs to be done. If I have the 5 on the outside of the parentheses, that is going to be my greatest common factor. So they're saying, well, one of the ways I can do this is by checking and filling in with zeros. All right. So if I check and I fill in with zeros, then I have 5 times 0 plus 4. And 5 times 0 plus 4, well, that would be 5 times 4, because I do the math inside the parentheses. Okay, easy enough. 5 times 4 is what? 20. What if I plug in the 0 for the x on the second expression? Well, I then have 5 times 0 plus 4. And 5 times 0 is 0, plus 4 is 4. So our conclusion has to be that these are not equivalent. So on this one, it tells us that we need to use the substitution method. We're going to do it 3 different times. We're going to use the values of 0, of 1, and of 2 to decide on if these terms are indeed equivalent one to another or not. So when it tells you to do all 3 of them using the substitution method, then yes, I expect you to do all 3 of the math problems on your assignment. So therefore, when I'm looking at 2x plus x, and I know I need to substitute in with 0, then I'm going to do that. I'm going to write out that math problem. I'm going to have 2 times x, so in this case 0, plus 0 plus 0. Substituted in a 0 for each of the x's. And when I do that, I end up with an answer of 0, because 2 times 0 is 0, plus 0 plus 0 is 0. I'm getting tired of saying 0. What about 4x? Well, if I plug in the 0 for the x and I take 4 times 0, I still get 0. So right now we're going to say they're equivalent. But I have to do it 2 more times. Right? So in science, we're going to talk about the scientific method. And when I have a hypothesis, I need to test it. How many times do I need to test it? I need to test it like 3 times. So there's a reason that we try this 3 times. Now we're going to plug in for the x 1. And now we're going to have 2 times 1 plus 1 plus 1. Well, 2 times 1 is 2 plus 1 plus 1. So that's going to give me 4. If I do 4 times x, which once again, the x is going to be equal to 1, 4 times 1 is 4. So far, we do have to say they are equivalent. One more try. We're going to test it a 3rd time. We're going to take and plug in for the 2's. And now, instead of 2 times x, we have 2 times 2 plus 2 plus 2. And that is going to be 2 times 2 is 4, plus 2 is 6, plus 2 is 8. All right, so if that's 8, what about the 4x? Well, that's going to be represented by 4 times 2 in place of the x, and that gives us 8 as well. So the expressions are indeed equivalent because they do have the same value when values are substituted in for the variable. If you get a question, hint, hint, that asks, well, can you explain why they're equivalent or they're not equivalent? This would be a good explanation as to why they are equivalent. They're equivalent because they have the same value when substituting in for the variable. All right, so now we're going to take it a step further. All right, so notice we have some exponents in here. We have the math problem, 1/2 x plus x squared plus 1/2, comparing it to 1/2 x plus 3x squared plus 1/2 minus x squared. All right, well, that seems like a lot of math, but it's not difficult math. I just have to follow my order of operations and plug in correctly where the x's are. So once again, they tell me to do all 3 of these. So I have to do all 3 of them, plugging in with a 0 for the x. So I have 1/2 times 0 plus 0 squared plus 1/2. Well, 1/2 times 0 is 0 plus 0 squared, which is 0 plus 1/2. That just gives me 1/2. What if I plug in with 0 over to the right? So 1/2 times 0 plus 3 times 0 squared plus 1/2 minus 0 squared. Seems like a lot of steps, all right? 1/2 times 0 is 0. 0 squared, because I have to do my exponents first, is 0. And then 3 times 0 is still 0. Plus 1/2 minus 0 times 0, 0 squared is still 0. So I still end up with 1/2. All right, what about with 1? So if they tell me I have to do the 1, then I have to do the 1. 1/2 times 1 is what? 1/2. Plus 1 squared, which is 1 times 1, which is 1. So now I have 1.5. And then 1.5 plus 1/2 gives me a total of 2. Okay, what about the second half? 1/2 times 1 plus 3 times 1 squared plus 1/2 minus 1 squared. Well, once again, we have 1/2 times 1. That's just going to be 1/2. When I do 3 times 1 squared, I see that the 1 squared is 1 times 1. So therefore, 3 plus 1 is going to be, or 3 times 1 is going to be 3 plus 1/2. So now we're up to 4, and then we're going to subtract 1 times 1, which is 1, and that gives me 3. Huh, that one didn't work. What about with 2's? 1/2 times 2, that's 1. 2 squared is 4, so that's 5. Plus 1/2, so that's 5.5, right? But if I plug in with 2's over here, then I have 1/2 times 2, which is 1. Then I have to do 2 times 2, because that's 4 plus 12. I jumped up to 13 plus 1/2 minus 4. 13.5 minus 4, that's going to give me 9.5. Those are not the same. So the expressions are not equivalent because they do not have the same value when x is equal to 1 and x is equal to 2. It's why we must do all three of them to prove if something is equivalent or not. We can't just plug in the 0 and say, oh yeah, I got the same answer. Well, that's not going to work when I do other numbers. So now we look at the idea of combining like terms. We're going to make this as easy as possible. If they are whole numbers, I will add or subtract them, whatever it tells me to do. If they are coefficients that have the same variable, so they have the same letter, and that letter has the same power to it. So if they're cubed, then all of them are cubed. But I will add or subtract them together. So notice the examples they give you. If I have 5 plus 2, well, 5 plus 2 just gives me 7. If I have 3x plus 5x, those are coefficients with the same variable. Their variable is x for both of them, so I can add my coefficients together. 3 plus 5 is 8, and just have the x behind it. So when I combine like terms, it's important that we follow those steps. So notice in this example, we have 2 x's, we have 4, and then we have 3 x's. And they're showing you in these tiles that if I shift and put all of the green tiles together, because they are all x, then I can add them together. In other words, I have two coefficients with the exact same variable, and therefore I'm just going to move them. I'm going to do the commutative property. I'm going to join them together, and since they do have the same variable, I'm simply going to add them together, and 2 plus 3 is 5, and I'm going to keep the variable, and then I'm going to keep everything else. So I end up with 5x plus 4. Well, what if I have x plus 5x plus x? Okay, so understand once again, that is the understood coefficient of 1 with each of those x's. So if I understand that those are actually 1x, right, then I can add them together. So it would be the same as saying I have 1x plus 5x plus 1x. And if I have 1x plus 5x plus 1x, because of those understood coefficients of 1, then I have coefficients with the same variable, and I can add them together. 1 plus 5 plus 1 gives me 7. And I simply keep the variable of x. Don't make this difficult. It's not difficult. Just look at what they have in common and do the math that's indicated. So it says to simplify 2x plus 5 plus 4x minus 2. All right, so the first thing I want to do is I want to write it. And then I want to do my commutative property and join them together. I would suggest that you box in your coefficients and variables so you know which ones go together. Keep that sign that's in front of the second one so that you know if you're adding or subtracting with it. That is important. I personally like to circle my constants. So I circle the addition of 5 and I circle the subtraction of 2. And then I'm going to do my commutative property. I'm going to put my boxes together. I'm going to put my circles together. And then I can just do my basic math. So I'm going to shift, or I'm going to adjust with the adding of 4x. I'm going to shift, or I'm going to adjust with the 5. So that's going to allow me to have 2x plus 4x plus 5 minus 2. In my associative property then, I see that I have coefficients with like terms. So I have 2 plus 4, which is 6, with the variable of x. And then I have constants. So I have 5 minus 2, and that's just simply going to give me 3. So I'm going to have 6x, going to do the subtraction, plus 3, because 5 minus 2 is 3. So my simplest form, my simplified expression is indeed 6x plus 3. So let's look at the check. I would, once again, box your coefficients and variables. You have 2x and you have plus 1x. Then, when I look at the constants, I'm going to circle those. I have plus 5 and minus 1. I'm going to do my associative or my commutative property. I'm going to slide them to where they're grouped together of boxes and circles. And then I'm going to do my associative property and put them in groups that associate together. Notice I have two coefficients with the same variable, so I know I can add those together. And then I have two constants, so I can do the math that's indicated there. When I have the same variable, I can add my coefficients. 2 plus 1 is 3. I keep my variable of x. I'm going to keep my addition, and then I'm going to have 5 minus 1, and 5 minus 1 is 4. My simplified expression is 3x plus 4. All right, so now when I do these, then I need to figure out how I can mark these up because I have different types of terms, right? So notice they're saying, all right, so let's just write our terms in these boxes. So how many x squared terms do I have? Well, I'm going to personally underline the squared variables so I can see the difference. But I know that I have 2x, I have a constant of 2, I have a constant of 6. Now I have these x squared. So my x to the second power, or my x squared, are going to be 5x squared plus, we have to remember that's an understood coefficient of 1, so plus 1x squared. My x terms, well, that's my blue box, and I only have 1. And then my constants, I have 2 plus 6, and 2 plus 6 gives me 8. So when I combine my coefficients that have the same variable of x squared, I get 6x squared plus the 2x plus an 8. So that becomes my simplified expression using my different properties. Once again, don't make it difficult. It's not designed to be difficult. It's just recognizing what the like terms are and combining them in the math that's indicated. So here we have cubed. Whew. So I'm going to suggest that you double underline. So now we've got 4 different things that we can have in our expressions. If I look at my cubes, that's to the third power. Then I have 2x, and then I have a plus x. That's the only cubed. Double underline any squared ones, so to the second power. I only have 1, and that's plus x squared. I will box in my coefficients with a standard variable, so to the power of 1, and I don't have any of those. And then I can circle my constants, and those are both additions, so I can put those together. So I want to be able to arrange these in order from largest to smallest. And my exponent of my coefficient will usually tell me which one needs to come first. So I'm going to keep my 2x cubed plus my x cubed. I'm going to slide my x squared over, so plus x squared. I don't have any with just a single variable, but I do have my two constants of 0.5 plus 1.5. Now, according to my associative property, I need to be able to combine my like terms. Remember that x to the third power has an understood coefficient of 1. So I actually have 2 plus 1, which is 3, and I keep my x cubed. My x squared just gets dropped down with the addition sign, and then I just simply combine my two constants. 1.5 plus 0.5, or 1.5 plus a half, that just gives me 2. That's my answer. Now, some of you are like, but I don't know what that equals to. And you won't, because that's not what the assignment is. That's not what the math is about. The math is about making it into the simplest equation or expression that we possibly can. All right, so what about this one? Well, I'm going to go through all my properties, right? So all we've done is added the distributive property, and that's okay, right? So I'm just going to start at the beginning. We're going to work through it. So I'm going to multiply by 3. 3 times 4 is going to give me 12. I keep my variable of x. I'm going to multiply 3 plus 1 or times 1, which is 3. I keep my addition. Then I have plus 2x squared, and then I have x. Remember, that's a coefficient of 1. So when I start my commutative property, then I want to put the one that has the largest exponent out to the left. So I'm going to slide my 2x squared all the way over to the left. Let's see. So I box in my coefficients and my variables, and I have two of them that have x, and then I circle my constant. All right, so let's slide all of those around and combine them together. So I have 2x squared, needs to go first, followed by 12x plus 1x. Those are like terms grouped together from the boxes. And then I only have one constant, which is plus 3. So now I'm going to combine any of my like terms, which I have two of them. I have 12 plus 1. 12 plus 1 is 13. So I end up with a simplified expression of 2x squared plus 13x plus 3. But I don't know what x is equal to. It's okay. You're not supposed to. Oh, this is a big problem. Yes, it is. It's a hard problem. No, it's not. Just start at the beginning because it's the best place to start. So when I see that I have parentheses, I want to do the math inside parentheses, but I don't know what that variable is equal to. So there isn't any math that I can do. However, I do have the 1/2 on the outside. That's my distributive property. So I'm going to go through that process. 1/2 times 2. Well, that's just 1, right? Because I put 2 over 1 times 1/2. Multiplication of fractions, that just gives me 1, right? So I have x squared. I don't need to put that 1 in front because that's an understood coefficient of 1. Then I'm going to keep my addition sign, and I have 1/2 times 1/2, and that's going to be what? When I multiply across, my numerators are 1, my denominators are 4, so that gives me 1/4, plus, well, I'm just going to bring everything else down, right? So if I have uh, things that have common variables and stuff, then I want to mark it up. So I see that I have squared variables. I have 1x squared and I have 2/5 x squared. And then I do have two constants. So I'm just going to commutative property. I'm going to move them to where they are joined together. So now I have 1x squared plus 2/5 x squared plus the 1/4 plus 7. Now I can just do my associative property and combine my like terms. X squared is going to stay the same, and I simply add 1 and 2/5, which gives me 1 and 2/5, and I keep my x squared. Plus 1/4 plus 7, and that just gives me 7 and 1/4. Once again, I don't know what the x is equal to, so there's not a final answer. That is a final answer. All right, you give it a shot. There's several steps to it, but I know you can do it if you just don't get overwhelmed with the math that's in front of you. All right, so if you have an answer, my question would be, did you start at the beginning and did you mark it up? So when we look at the math, right, we have 1/4 times 4x plus 12 in parentheses. I can't do anything with that variable on the inside of the parentheses, so I'm going to do my distributive property. Hopefully you did that, and that's where you started. So you did 1/4 times your 4, and those 1/4 and 4 over 1, that just cancels out, and that just gives me my x, right? Or my understood coefficient of 1. And then I multiplied 1/4 and 12, and 1/4 times 12, well, I have to do the 12 over 1. I, once again, like to cross reduce. 4 will go into 4 once, and 4 will go into 12 3 times. And then I can multiply across, and I get 3 over 1, which is just 3. All right, keep my addition. And then I bring down the 1/2 3, or x, excuse me, plus the 1, plus the 3/2 x. Okay, so now what do I have? So now when I start looking at my boxing my coefficients, when I have straight variables, I have 1x, I have 1/2 an x, and I have 3/2 x. Okay, and then I have two constants. So hopefully you did your commutative property and you added and shifted and you got 1x plus 1/2 x plus 3/2 x plus then 3 plus 1. And then when you looked at adding those together, well, what does 3/2 look like? Well, when I actually change that, then I know, or hopefully I know, that that's 1 and 1/2. So what we really have is 1 and 1/2 plus 1/2 plus 1. So if I look at 1 and 1/2 plus 1/2, well, then that's 2, plus 1, then that's 3, right? So when I get a whole number of 3, then I just keep my variable of x. Did you get there? And then hopefully you ended up with 3 plus 1, and you got plus 4. Did you finally get to that final answer? All right. So that is your lesson. It's just combining like terms. If you have questions when you're doing your assignments, then please come and ask. You will have a couple word problems to go along with this. And once again, I would suggest that you cube your word problems so you know what to do.